And I think we've talked about much of this. We're just going to sort of solidify it a little more. So we're going to be talking about how compounds are made, why different atoms bond with each other, and in what proportion. So we can predict that. So first thing to think about is all atoms want one thing. Okay? Now they don't really want anything. They're inanimate objects, but we're going to talk about them like they're people. All atoms want one thing. They want to be stable.
I knew it.
And for an atom, stable is having a full outer shell of electrons. Now, often that is 8 electrons in the outermost shell. And so that leads us to this concept that's called the Octet Rule. Okay? So all atoms will form compounds in order to reach 8 electrons in their outermost energy level. Okay? Atoms that have less than 4 in their outer level tend to lose those extra electrons, get rid of them, because once they're rid of those, the shell before that is full. So if they get rid of those extra ones, they're kind of hanging around, then they have a full outer shell. Atoms that have more than 4 electrons will generally try to gain electrons until they can reach 8, until they can reach a full outer shell, and then they'll be stable. So that's the Octet Rule. Okay. So whenever we're thinking about this, we're looking at the outermost electrons. And we know the electron configurations listed in the lower part of the periodic table entry. The borons is 2, 3. Bromines is 2, 8, 18, 7. Okay. So those outermost electrons, they are called valence electrons. And so what we are going to start to figure out is something called the valence number. The valence number is basically telling how many electrons this atom would like to gain or lose. How many extra electrons it has or how many it's missing. Okay? So, the valence electrons in the outermost shell. How many valence electrons are there in boron?
3.
There are 3. So, what would it like to do? Yeah, I'd like to get rid of those 3. It has 3 extra electrons. Bromine, how many in its outermost shell?
7.
Okay.
It wants 1.
It's missing 1 in order to be full. And so, you see this number in the top right?
Yes.
It's often called the valence number. So what it's saying is that boron has 3 extra electrons. What is the negative one? It's missing 1 electron in order to be stable.
Everything makes sense now.
Those are the electron shells. Those are the valence electrons. Those are the valence number, also called the oxidation number.
George, we have to label
Yeah,
all
right.
these.
Yep. And so this is, once you understand the process, it's actually pretty simple. We're going to look at those valence electrons, and you can tell if this atom has extra electrons or if it's missing electrons.
Wouldn't we just be able to tell anyways because like whether it's closest to 8 or 0?
Yeah. Less. And so when you guys look on your periodic table, there are no oxidation numbers. They're not listed. On some periodic tables it is listed. But yours are not because we're going to be figuring it out. You're going to have to know how to find the oxidation.
Don't you need to get it?
So let's look at some examples. Sodium. Outermost energy level. How many valence electrons?
An extra
1.
It has, look at its outermost energy level, it has 1 valence electron. Raise your hand then. What is its oxidation number then?
1.
Laura? Down. Laura? I need a symbol with it.
Oh, plus.
Plus 1. it has one extra electrons. Think of the plus sign as meaning extra. So sodium, if it can get rid of that extra electron, how many would it have? 8 in its outer shell. It would be very happy. Chlorine. Raise your hand. How many valence electrons? Yeah?
7.
Has 7. So what would its oxidation number be? No? Shane? -1. It's missing 1 electron in order to be stable. It's -1. If it could borrow that and get that electron, how many would it have?
8.
8, and it would be stable.
That is
Get it. Oh my god.
Carbon.
That's basically all elements.
Yeah, well, not all.
Yeah, but
There's one group that's separate. All right, carbon. What about carbon? How many valence electrons? 4. So carbon's a little weird because it can be plus or minus. Sometimes it will gain 4 electrons to get up to 8. Other times it will lose those 4 electrons. It depends on what it's going to be combining with. Gallium, 2,8,18,3. How many valence electrons?
3.
Oxidation number then should be
+3.
+3. Has 3 extra electrons it would love to lose.